Hello, everyone. Can you hear me? Okay. So it is now, it is 1 minute before the time. So I wait another minute. So in the meantime, if you want to ask any questions, you can go to the right of your screen and there is a tab that is named Q&A. And in the Q&A, you can write your own questions so that we can pick your questions and ask Ralf directly. So if you have any questions, please write them down in advance in the Q&A tab in the right of your screen. Okay, now it is the time, so I'd like to begin the AMA of Ralf Jung. Welcome to Ralf Jung's AMA on Rust, and my name is Jiun Kang, and I'm also excited about this AMA because I'm a big fan of Rust. Ralf Jung is a postdoctoral researcher of Max Planck Institute for Software Systems, where he received a PhD from Dr. Derek Dreyer, and he is moving to MIT next week. His foundational work on understanding and evolving Rust reveals the underlying structure of the practice of Rust for systems programming and invites a lot of programming language researchers to Rust, including myself. And his work is widely recognized, and he recently received the ACM Doctoral Dissertation Award Honorable Mention. Now let's start the AMA, and you can ask questions in the Q&A tab on the right of your screen. And I'd like to have a privilege to ask the very first question of this AMA, which is that, Ralf, would you please introduce yourself?
Well, thank you very much for the introduction. I think you already did most of my work here. I mean, as you said, I'm Ralf. I live in Saarbrücken, which is a beautiful city in the west of Germany and a great place to do computer science. And I lived here for 11 years now, doing my undergrad, doing my PhD, and some amount of unplanned postdoc due to a certain pandemic. And I'm going to leave this week to do a postdoc at MIT, which I'm also very excited about because I'm kind of moving from the PL side of things towards the system side of things, also in terms of the people I'm working with, I guess.
So there is no question so far. Oh, there is one question here. So I'd like to, so I'm not a host of this session, so I cannot make it visible to all of you, but I will read it. As time progresses, Rust is accumulating more and more stuff, making the language increasingly complex. C++ shows that there are downsides to this kind of language growth. How do you feel about this?
I mean, I fully agree that this is something that one needs to be aware of when designing a language. I should also add that I'm not on the Rust language team, so I'm not really involved a lot with designing the language, or at least its user-facing parts. I mean, I'm interacting with the language team a lot on the nasty details of unsafe code and things like that. But I have nothing to do with most of the language. But the language team is also certainly very aware of this. And I think if you go through the release notes of the last couple Rust releases this year and last year, most of the things that were added are more library functions. So I don't there haven't been many big language level features that have been added recently. I think pace has been slowing down in that regard, and it's moving towards maturing the standard library. So I'm not currently worried, but this certainly needs to stay on the radar of the Rust language designers.
Okay, so if you have any further questions or follow-up questions, please ask again so that we can handle the follow-up questions separately. So still there is another question. What are the next steps for stacked borrows? So maybe you should first explain what is stacked borrows first briefly and then answer this question.
Yes. Thanks, Hanali. This is a question about stuff I actually did in Rust, indeed. So one of the things that makes Rust so interesting and unique is its take on reference types, which is inspired by a lot of prior work on region types in academia, but hasn't really been seen in industrial languages before, where you can basically either have only one reference anywhere in the program to a certain data, and then that's a mutable reference, or you can have many references, and they will all be shared references and will all be read-only. And from the beginning, even before I had anything to do with Rust, the designers noticed that this could be useful for optimizations, because there's some amount of aliasing information embedded here. If you know there's no aliases at all, that's useful for a compiler. If you know that all the aliases are only used for reading, like in the case of shared references, that's also useful for a compiler. It's almost equally useful. And Stack Burrows is a proposal for how to make those aliasing guarantees for Rust into a formal, like how to make them formal. Because the problem is, if you just write safe Rust, we could just prove theorems about references and we could use them for optimizations. But because Rust also allows programmers to write unsafe code, which is probably the other biggest thing that makes Rust so unique and that contributed to its success, there are some ways there to break the rules of references, and we need to be very precise about which amount of rule breaking is okay and which amount of rule breaking is not okay. And so Stack Burrows is a proposal for that, in the form of an operational semantics that tells you exactly if a certain program is following the Rust aliasing rules or not, which I've implemented in Miri during an internship with Mozilla, so you can actually run this as a test on your code. And then I worked with Hai and Jihoon, in fact, to build a formal model of this in Coq and make some formal proofs about this. And so the next steps are, well, if you go to the Rust Unsafe Code Guidelines Working Group issue tracker, there are like 12 or 15 open issues with Stack Burrows being tracked there. Mostly around, there are some programs that Stack Burrows rejects, where it says that those are not okay programs to do, which we don't really have very good reasons to reject those programs. They seem fine. They don't break optimizations like on their own, it seems. So I have some ideas for how one could possibly make Stack Burrows more permissive while still maintaining these optimizations, which will be important in particular since some of those patterns involve like the kind of programming that systems people really like to do. Like having a pointer into the middle of a struct, but having implicitly some header information at negative offsets and things like that, which are currently not well supported in Stack Burrows, but which Rust programmers just want to do. And so the next step there would be finding ways to enable those in Stack Burrows without sacrificing too many optimizations.
Okay, thank you for answering this question. And let me move on to another question from Hai. Apart from your contributions to formalizing guarantees that Rust claim to have, what other tools are or will be there that the Rust language community can rely on for their safety claims?
I mean, there's already a notable suite of verification tools for Rust, right? Alastair Raid has a great list of Rust verification tools that you can find on the internet if you Google for it, which includes things like basically applying existing C tools to Rust, which you can certainly, which will help Valgrind and UBSAN and those kind of things, or interesting static verifiers, which is kind of outside my realm of expertise, but those can also be applied to Rust to prove safety, or at least to prove UB freedom of certain amounts of code. Two specialized Rust tools like Prousty that other researchers have developed, and I'm sure more of those will come. I mean, just this week I saw somewhere popping up a paper about people using static analysis to automatically detect undefined behavior that they ran on like all of the Crates.io ecosystem and found like 80 or something critical security issues with that. So I think there will be a lot of tools, and that's great. And they will use all the approaches from like formal manual verification, automatic verification, fuzzing, testing. I think we should throw all the tools we have at this problem to see how we can help programmers that have to use unsafe Rust, and even programmers that use safe Rust, because you can still have bugs in safe Rust, obviously.
Thank you. And here is the next question. I taught a program course about Rust last spring semester. One difficulty that I encountered relative to other statically typed language is that I often wanted to express negative information to get confirmation from the compiler. So probably the remaining part of the question is how to do that also in Rust, or how do you handle when you need such feature?
Okay, I'm not quite sure what is meant by negative information here, but one thing that maybe you mean here is making sure that certain code does not compile, which there's a follow-up. Yes, so the Rust has this Rust doc tool, which you can use to write tests in your documentation of Rust functions. And when you run cargo tests, those doc tests will be executed, which is something that Rust took from, I think, Python, from some existing scripting language community, I think, is where this idea originated. And the Rust doc supports compile fail tests. So you can write code that is supposed to not build and have cargo test ensure that it indeed does not fail to build. That's not extremely precise, but that's a start. And then there is a great crate by D. Tolai, who wrote a huge amount of great crates, like the author of Zerdy, for example. Though I forgot the name of this particular crate, which you can use as like a UI test suite for proc macros. So that will also, and I would imagine you could also use this for non-proc macro crates, where you can then even ensure that like certain error messages are shown when you invoke code in the certain incorrect way. So that's if that's what you mean by negative information, that's probably what I would start with.
Okay, here is the next question. Here are a lot of questions here. Mirror's continuous improving correctness of the Rust ecosystem. Are there plans or work in progress to expand the list of undefined behaviors that it is able to catch?
No work in progress from my side currently, though it has happened multiple times in the past that people just show up with a huge pull request implementing like unwinding or data race detection in Miri. Suddenly people, like on the internet, amazing things can happen. So no way to predict that. The list of UB Miri detects is fairly, I mean, it's not complete yet, but the two biggest things where it is not detecting currently are, well, one of them is just the questions are still open around what exactly are the validity requirements for, like, is it okay to have an uninitialized integer that you're not looking at and things like that, where I do plan to have some flags to offer stricter checks there. But really the biggest thing there is to have a structured discussion with the Rust language team and the community to start finding consensus on those rules. And also stack borrows, of course, the next version of that, which we already had a question about. And then I think I also saw this pop up in some question, weak memory, which the cone data race detector doesn't model. And I don't have currently any plans to go there. I haven't done any work myself on weak memory. I'm not even sure what the state of the art is in terms of dynamically executing programs with weak memory and detecting data races, given that weak memory models are typically axiomatic and not operational. I think the bigger problem there is that when you do this with concurrency, you have huge amounts of non-determinism. So the Miri approach of just running the program and looking for UB will only explore one execution. And you really want that might not be enough. And I don't know what the best answer for that is to have Miri randomly explore multiple schedules, but then most of these schedules are going to be irrelevant. Maybe there's some amount of partial order reduction that could help here. People have done stuff there. I don't know how much of that will be useful for a full tool like Miri, but I guess we'll see. There's also a great tool that the I'm forgetting all my names. There's a great tool for doing weak memory testing with Rust. That
probably you can proceed on the next question naturally. Probably
yeah,
you're
Loom,
meaning
right.
Loom.
Loom is the tool I was thinking of. Yes.
Yeah. So
right. So I think I basically answered this already. I don't have currently plans to add weak memory models to Miri, partly because I wouldn't know which memory model to add. There's like many of them. And I'm not personally a big fan of axiomatic models. I like to think of computers as operational. Also, that makes it easier to implement this in Miri. But the promising semantics doesn't seem to be exactly something you could easily implement in Miri. At least the promise is part of it. So I don't know what would be the best next step there. It would certainly be very interesting to have something that can detect more of these undefined behaviors. Though I'm not even sure undefined behavior is the bigger problem there. The bigger problem there is like the allowed behaviors. We are already detecting data races, but we are not exploring any of the executions that weak memory systems are allowing. So there's just real programs can read values that Miri will never read in a concurrent execution. So it's less about detecting more UB and more about allowing more values to be read, which then gets us into this non-deterministic problem, which Loom is, of course, a completely different approach for that. Maybe there's some nice way to combine Loom and Miri. That sounds like a very interesting thing someone could do.
Okay, thank you for the detailed questions. And I'd like to show this question on the stage. How did your team came up with the idea of Ghostcell, a paper on the main track?
Right, so this was entirely Josh's idea, Josh Iganovsky, first author of that paper. If you want to go hear all the details, I actually recorded a podcast about that a while ago, which you can find on the Ghostcell paper website. But very roughly, Josh was working on basically a Rust implementation of cockcheck, which is the cock kernel tool that you can use to check a cock.vo file if it's actually a correct cock proof. And so he had these huge, terms in the CSE language of cock in Galena, which are big graphs, and he had to do things on those terms. And so he thought a lot about graph traversal, and of course he wanted to make it concurrent and fast. The idea was that the Rust thing would be much faster than the Okama thing. And as part of that, I guess he came up with Ghostcell. That's as much as I know about it. As far as I'm concerned, Josh and me sat in the bus someday, and he pitched this idea to me. So I don't really know a lot about that backstory. It took then a while after he had the idea to develop the proof. By a while, I mean like a year or two. But the original idea, I think, was while implementing a Rust cockcheck. But I might be wrong about that. Josh would know better.
So thank you for the backstory of the paper. I believe that your story, the story you tell you right now, is not describing the paper, right?
No. I mean, I don't think this cockcheck tool was ever completed. So I mean, 25 pages might seem like a lot, but they're really not. As anybody who submitted a paper to ICFP or other conferences knows, is never enough space. Mm-hmm. So we tried to come up with examples that we can actually reasonably explain, and the doubly linked list was much easier for that than the general graph. Well, a general graph library wouldn't even have been the original thing, right? Like a cockcheck tool that would have been awfully specific.
Mm-hmm. I see. So here is a follow-up question from Matthew on the negative reasoning in Rust. So he really liked to be able to express that as this value is still borrowed at this point. So would you please explain how to do that, or why it is impossible?
I'm not entirely sure I understand the question. This might be something we might have to chat about at some point. If I wanted to express this in a test, I would usually just call a function and give it a borrow to ensure that it's okay to still give that value away, or to have that call in a compile fail test, which then would ensure that that you can't give it away at this point. But I think this is very hard to discuss in the abstract.
Right.
So also, I mean, the borrow checker is still going to change. So there's a small chance, but maybe that's what the question is about, that like more programs will be allowed in the future. Hopefully not in ways that break existing APIs. Yeah.
Okay, here is my own question. You are one of the first PL people who recognize the importance of Rust and worked on it. Now you are the leading figure in this important area. Is there any special event that helped you to look into this topic in the first place?
Yeah, I mean, I think this has been many years ago, obviously. So my recollection of this is probably more the story I tell myself than what actually happened. But I think, I was working with Aaron Turon, who was a postdoc with Derek. We overlapped a bit when I started with Derek. And then Aaron was going to Mozilla to lead the Rust team. So that was an obvious moment in time to look at Rust again. I had heard about Rust before, back when it still had ats and tildes and a lot of sigils. And I was like, that sounds interesting. And then didn't look at it again. But then around the 1.0 release, when Aaron, I think he moved like half a year earlier or something, I started to really look into Rust more. And to properly learn it, I gave a little Rust course at MPI in Saarbrücken. And then came the time to discuss with Derek what my next research project would be, because Iris was kind of on its way, but the first Iris paper was out, and at that point didn't seem like there would be a lot of stuff still. Well, I mean, there was going to be something that I would build on top of Iris. And Rust seemed extremely interesting. And of course, Derek already, like, being one of the people to root for the semantic approach to typing, we were exactly in the right spot at the right time to tackle the unsafe code issue in Rust. Like, it was almost as if the problem was written for us. So a lot of luck and being at the right place and the right time, and it gladly worked out.
Thank you for answering my questions. And unfortunately, I need to show my question. Whenever I see you, you are always passionate about your work, which I found is contagious. How do you remain so motivated even at difficult times?
I don't know. I'm happy that that you can see that I love my work. It's mostly I pick whenever there's questions about which projects to do. I usually try to pick the one that's most fun, which is not a luxury that everyone has. But when it's a strategy that you can follow, then I think it naturally leads to you being excited about your work because you're doing it for fun, which is, I mean, how I hope much research happens. But I guess there's always some amount of, like, things become too hard, and there's some amount of grind, and you're not always in the mood to fight LaTeX. But no, mostly it's just a lot of fun. I mean, I get to think about hard problems. I get to work with smart people all over the place. I get to fly to weird places all over the planet, and I get paid for that. I don't know how I got so lucky, but I'm enjoying the ride.
Okay, thank you for answering this question. And actually, the only remaining question is also mine, so probably I need to wait for another question. Yeah, here. Okay. Were there any particular design choices Rust made that were difficult to describe with stack borrows, or did everything most to fall into place naturally?
That's a good question. So stack borrows is kind of the second attempt already at, like, solving this problem of defining an aliasing model for Rust. The first attempt is what I did during my 2017 internship with Mozilla. Stack borrows is what I did during my 2018 internship-like thing with Mozilla. And the 2017 version, you can find it on my blog post. I adopted types as contracts. So the idea was to have preconditions and postconditions on all functions given by the argument and return types. And it would very eagerly check a lot of things about those. And the things it would check about references would involve making sure that the aliasing the alias guarantees are upheld. Which was, of course, directly inspired by, like, the semantic model we built for Rust Belt. So it was like, okay, every type has, like, an invariant associated with it. The Rust Belt invariant is an Iris invariant. You can't just check it at runtime. But if you add some runtime instrumentation, and I had this idea of, like, having locks on memory, read locks or write locks, and then you could check a whole lot of things about that. And that didn't really work because there was just too much code that didn't follow the discipline, too much unsafe code. It was very, like, when there was a bug, this approach was very good at pointing at the right spot where the bug actually happened, where stack borrows, usually the bug, like, the thing that mirror points you is way later than where the actual problem happened. But it was just, so sometimes comparing early was good, but in many cases, it just didn't accept code that really we should have accepted, or everybody agreed should be accepted. So then there was this choice was made to basically try to check less upfront and more only on actual uses. Though I do still have this thing where stack borrows is checking on every time you create a reference and every time you pass it to a function, which is something I might have to reduce further as part of this earlier question, right, about next step for stack borrows, because there's still code that where this checking is too aggressive. The other hard thing was unsafe cell. I mean, Rust says shared references are read-only, but then except when they are not, right? Because we have interior mutability, and we have these cell types where you can actually mutate shared data, which of course completely breaks that promise and breaks optimizations, which is why the programmer, when writing a cell type, needs to use this special magic type unsafe cell, which tells the compiler that interior mutability can happen. And so the stack borrows clearly had to somehow do something with that. But that went through quite a few iterations, and it was really hard to find a model that actually accepted enough real code. I mean, there's some really weird code you can write where you give an ampersand ref cell and a ref to a function, and they're both alias because the ref is actually pointing to the same ref cell that you're also giving to the function. So you actually have aliasing shared references passed to a function. And the ref doesn't even have an unsafe cell in it anymore. Only the other side does. And like supporting all of those cases was pretty tricky. And there was one case where I basically give up on, which is this thing called two-phase borrows. I'm not going to go into details here, but you can find it online, where stack borrows currently basically gives no guarantees at all and no restrictions and no optimizations, because I didn't find a model in the stack borrows framework that was really helping and giving optimization. So that's also something that maybe would get better with a better model.
Okay, so here is another question from Hi. How would the refinement type approach like refine C compare with stack borrows? Is it more closely related to your first attempt?
I mean, refined C is more of an approach to verify programs, and stack borrows is an operational semantics which defines what it even means for a program to correct. So I find it a bit hard to compare the two, but of course, it would be really interesting to have a version of refined C for Rust that actually then also takes into account the stack borrows rules and proves that your code is complying with stack borrows. Yeah. That's I mean, refined C for Rust is something that's a project that's a very natural next step. But then doing that with stack borrows also in the mix is going to be a lot of work, and probably a bit further into the future.
Okay, finally, I'd like to ask my own question here. You are also actively contributing to the Rust language and compiler and many other open source projects. How does it relate to your research? Do you get academic motivation from open source projects? Conversely, do you apply academic ideas to open source?
I definitely get academic motivation from open source projects. I mean, that's how stack borrows happened. And Miri, hopefully at some point, well, Miri is this funny thing where, I mean, the stack borrows paper talks about Miri, but other than that, Miri is not really, I've not really done much academically with Miri. I just wrote a lot of code and maintained the software. But that also seems like something that maybe one can write a paper about at some point, maybe in combination with like some formal artifact of some sort. I don't know. So I definitely get academic motivation from just looking at what happens in the Rust community. Pinning is something that I would like to look at some point, which just like there's so many things happening in the Rust community, interesting patterns that people come up with. I mean, the amazing thing is that Rust basically enables programmers to come up with crazy things that they can write in unsafe code, and then put a safe API on top of it, and then let people evaluate whether that safe API indeed is safe or not. Which is, if you would explain this academically, this is an extremely hard problem. Like formally proving this requires something like Rust Belt, and it's extremely theoretical in a sense. But by putting this into Rust, it's suddenly gotten a lot more accessible, and systems programmers are coming up with crazy abstractions that I have no idea how they come up with. I can barely understand what's going on and try to find the formal argument for why it's correct. So I think this will be a good inspiration for research problems for quite some time to come. And then for the last point, do you apply academic ideas to open source? It's more like the opposite. I apply open source ideas to academia. This is more accurate for Iris than for the other projects I do, I think. But Iris is certainly something that I kind of, well, I was pushing my co-authors and they were happily going along to running this like a typical open source project. So we have a public repository, we have public issue tracking, we use a merge request-based workflow with the code review and stuff. We have continuous integration. We have a public chat to coordinate development, but also coordinate with users. That was just things I learned from being active in the open source community already before I did research. And I was like, well, I mean, like for Iris, we want people to use it. The code is open, so we just do what the open source people do because it works for them. And I think it could work for us, and it has worked for us.
So we are running out of time, so I am going to be very quick. So what about integer pointer casts in Rust?
It's as much of a mess as with C++, I think is the safe answer.
Okay, here is another question. What are you gonna do at MIT?
Um, well, so I'm joining PDOS there, the Parallel Distributed Operating Systems group. So there's certainly going to be some amount of working on parallel distributed systems, in particular using Iris maybe to look into distributed systems and crash safety of distributed systems. So that's not Rust related at all. But I sure will continue doing some amount of Rust stuff, and I hope there will be some opportunity to do Rust research also there. Ideally with some, I mean, I can only do so much research alone, but maybe there's some undergrad or PhD student there that wants to work with me on Rust stuff. I'm sure we could, sure some interesting project could happen there, but currently it's not yet clear.
Thank you. So probably the time is up now, and I'd like to end the session with you, Ralf, saying anything you want. So would you please say anything you want to tell everyone here? Lastly.
Ooh, I'm not prepared for that question. Well, I mean, thanks all for the nice questions, and Jihoon for moderating, and thanks everyone for coming. It's extremely gratifying when you do some work and you see people take it and run with it. So I'm humbled and amazed by the kind of things that people do with Iris and with Rust and with the work that I did and with the work that many other people did. It's always a big teamwork, and it's great to see where we can go if we all work together.
Thank you so much. Thank you for answering so many questions in so much deeply manner, and thank you so much.
Thanks.
And yep. Is it expected?